most important theorem, so that is P series test. So it is also called as hyperharmonic series or auxiliary series statement. The infinite series summation of 1 divided by n to the power of p is equals to 1 divided by 1 to the power of p plus 2 to the power of p, so on up to the 1 divided by n to the power of p. So this continues up to infinite series is convergent if p is greater than 1 and is divergent if p is less than or equals to 1. Okay, three conditions are there. So in the case 1, consider the first case, so that is p is greater than 1. Okay, so first term 1 divided by 1 to the power of p, for p is greater than 1, p value whatever it may be 1000 together, so it is 1 only. Okay, so that is one term. One term means, so we have to consider it as 2 raised to 0, that is one term. 2 raised to 1, so we have to consider the two terms. 2 raised to 2 terms means we have to consider the 4 terms. 2 raised to 3, that is we have to consider from 8 terms. Okay, so like that the series continues. First, that is 2 raised to 0, one term is completed. Next term, next consider 2 raised to 1, so 2 terms we have to consider. So that is 1 divided by 2 raised to p plus 1 divided by 3 raised to p, so that is a logical assumption. So clearly which is less than 1 divided by 2 raised to p, 1 divided by 2 raised to p. So here we have to consider 2 terms, means here also we have to consider 2 terms. If you consider 4 terms, so here also we have to consider the 4 terms. 2 raised to p plus 3 raised to p. So if you consider these terms in the numerator, so clearly this LHL value is greater than this RHS. But here if you consider these terms in denominator, so clearly, so which is less than this term. Two terms are there, 2 divided by 2 raised to p, that is 1 divided by 2 raised to p minus of 1. Okay, next consider the 2 raised to 2 terms, means 4 terms you have to consider. So that is 1 divided by 4 raised to p plus 1 divided by 5 raised to p, so on up to the 7 raised to p. Clearly this value is less than, so starting terms we are considering. So here in the first case, for p is greater than 1, for p is less than, so we have to consider that end terms. Okay, so 4 terms, so here also we have to consider the 4 terms. Take the LCM, so it is 4 divided by 4 raised to p, so that is you take that 4 denominator, so 1 divided by 4 raised to p minus of 1. 4 means 2 raised to 2 to the power of p minus of 1. So this is the value related to 2 raised to 2 terms. Next we have to consider the terms 2 raised to 3, that is 8 terms we have to consider. 1 divided by 8 to 1 divided by 15, so 8 terms are there. So clearly, so here also we have to consider the 8 terms, that is 8 divided by a raised to p, take that into denominator, 8 raised to p minus of 1, 8 means 2 cube to the power of p minus of 1, that is 2 raised to 3 terms. Like that this series continues up to n number of terms. So consider that infinite given series. Okay, so according to this, so we have to make the group. So first we have consider one term, means, so that is one term. Next 2 terms, so make that group. Okay, next 8 terms. Okay, so call it as equation number 1. So in this series, so we have to substitute that related values. 1 divided by 1 to the power of p, so its value is 1, so put 1. Next 2 terms we have to consider, so its value, that is 1 divided by 2 raised to p minus of 1, substitute that value. Next for 4 terms we have considered, for that we have to substitute that 2 raised to 2 to the power of p minus of 1. Next we have to consider the 8 terms, for that related value is 2 cube to the power of p minus of 1. Okay, so consider that call it as equation number 2. Okay, clearly, so this term divided by this term, that is any previous term divided by its any term divided by its previous term, so its ratio is constant, so that is GP, that is geometric progression. Clearly this series is in GP, so and its common ratio is 1 divided by 2 raised to p minus of 1. Okay, so this term divided by this term. Okay, that fourth term divided by third term, so its ratio is 1 divided by 2 raised to p minus of 1 only. Okay, so therefore 1 divided by 2 raised to p minus of 1 is less than 1 when its p value is greater than 1. So here first case we are considering as p is greater than, just by substituting p greater than means consider 2 or 3. If you consider 2, so it is 1 by 2, so clearly, so its value is 0.5, so that is less than 1. By increasing p value also, so its value is less than 1 only. Okay, so according to geometric series, so theorem we have proved. So according to that theorem, so clearly if that value is x value is less than 1, clearly it is convergent, hence the given series is convergent. Similarly, consider for the case 2 for p equals to 1. Okay, so that is if p value is equals to 1, so that is, so in this series, so we have to consider p value is 1 1 1 means, so it is 1 plus 1 by 2 1 by 3 1 by 4, so it continues up to a number of terms. Okay, so first you have to consider 1 plus 1 by 2, so clearly this value is greater than 1 by 2. Or if you consider 1 by 2, so that is 1 by 2 equals to 1 by 2. So here two options are there. So accept the first terms in this series itself, or if you consider this 1, so at the while considering geometry progression, there we have to leave the first term. Okay, so both are same, so leave this red so whatever we have written on the red pen, so that leave it. So consider that 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, so that is 1 plus of 1 by 2, so that is greater than 1 by 2, so that is equals to 1 by 2 means, so that is 1 by 2 itself. So next consider the two terms 1 by 3 and 1 by 4. Clearly this value is greater than 1 by 4 plus 1 by 4. So here we are considering that edge terms. In case 1 we are considering the first terms. Okay, two terms means here also you have to consider the two terms. Take that LCM 2 by 4, so it is 1 by 2. Next consider the four terms, 4 divided by 8, so that is 1 by 2. So consider that infinite series according to this group. So whatever we have made, so according to that, so make that group. So call it as equation number 3. So in that equation 3, so whatever that related values are there for the first, so it is 1 by 2. So substitute that is 1 by 2. Next 1 by 3 plus of 1 by 4, so it is 1 by 3 plus 1 by 4, so its value is 1 by 2. Next 4 terms are there, so it is 1 by 2. So like that the series continues up to n number of terms. Okay, so since the equation 4 leaving the first term in a GP, so this first term, so we are neglecting this first terms, so that remaining values are in GP, so whose common ratio is 1. Okay, for that purpose, so we are considering 1 plus 1 by 2, so that that is greater than 1 by 2. So in combination of these two terms, so we are considering as 1 by 2 by leaving the first term in a GP whose common ratio is 1. Okay, so in this series 1 by 2 1 by 2 1 by 2, how many 1 by 2s are there? N number of 1 by 2 are there, so that is Sn value. So if you apply limit to this as n tends to infinity, so that is infinity only. So according to that GP, so if it is an infinity, so it is a divergent, hence the given series is divergent. Okay, so in case 3, so that is if p value is less than 1. Okay, so this is for p equals to 1, and first one is p is greater than 1 and p is less than 1. Just logic, n to the power of p value is less than 1 means n to the power of p must be clearly less than 1, because it comes under decimal, so it is clearly, so they are less than n. Okay, for p is less than 1. But if you consider this in denominator, clearly this is sign will be reversed, less than becomes greater than 1 by n for every value of n. This 1 divided by n to the power of p from the case 2. The series summation of 1 divided by n is divergent here. So clearly this is 1 divided by n to the power of p greater than this value. Okay, but 1 by n, so here 1 by n, summation of 1 divided by n in the case 2, it is divergent, and also this value is greater than 1 by n means clearly if this is divergent means, so 1 divided by n to the power of p, so that is also divergent. Hence according to p series, the series is convergent if p value is greater than 1 and is divergent if p is less than or equals to 1.